Currents. This week on Current Events. I really like currents because look at these pretty maps. Really, that's what it comes down to for me. You can see all sorts of depictions that integrate color and art into the way that we understand about things like temperature anomalies or distribution of heat and moving water. This is a particular map of the Gulf Stream current. That's Florida right there, this warm fire hose of water shooting up into the northern Atlantic. Now, currents are really complicated. There's two main types of currents, and I want to show you how some of them work. The two main types of currents are ones that are based off of density and ones that are based off of wind. Let's talk about density for a little bit. We know that density causes things to either float or sink. If you have a warm body of water or a warm body of air, it's less dense. That means it floats. Cold things tend to
sink.
Perfect. What if I dump a bunch of salt into water? Does that make it denser or lighter? Denser, so it will. Fresh water doesn't have salt, so it will. Perfect. We know exactly what's going on here. Don't mind if I spill a little bit of water. Don't worry, we're 70% water. We're going to do a little bit of an experiment here. I have some really salty water and some very fresh water. We're going to mix these together and do a little bit of an experiment. But of course, we're good scientists, which means that we make hypotheses and observations. So, I'm going to add some food coloring so you can actually see what's happening. We know that there are two main ways. Dense things and cold things sink. This is dense because it is salty. And we know that fresh things and warm things rise. So, let's make some hypotheses. I'm going to need a volunteer. Who wants to help me out? Khadija?
Yeah.
Come up on stage. So, before Khadija pulls this little separating barrier, we need to be scientists and make a good hypothesis. We have dense water and fresh water. What would happen if these two bodies of water were to come into contact?
Lightning from her
Absolutely! Red would go on top? Let's see. Go ahead and lift the flag. Any speed you want. It doesn't matter. Try to see if you can see. These interactions between dense and fresh water are analogous to the exact same way that this current moves around the world. This is the global thermohaline ocean circulation, also called the deep ocean conveyor belt. This chain of water, of warmer water and saltier, colder water, moves around the Earth in a cycle that takes 1,000 years. If you were to throw a neutrally buoyant orange into this current, Europeans wouldn't even have landed on the continent of North America by the time this would have gone around once. We're talking about one type of water and current movement. There are others, though. The other type is wind-driven. These gray arrows represent wind, and these other colored arrows represent the ocean currents. Wind is the driving force between things like the Kuroshio current off Japan or the Gulf Stream current off of the east coast of America. Why do we have ocean currents that go around in big circles? Shouldn't they just kind of flow in straight lines until they bump into something? Well, it gets really complicated at this point, so I'm going to explain something called the Coriolis Force. What happens if you have a merry-go-round and you're spinning around and you decide to throw a ball? Because of the movement of that spinning, you're never going to be able to catch it on the opposite side in the straight line of where you throw it. It'll move and deflect because of the motion of the things spinning underneath it. The Earth works the same way. any motion on this huge spinning globe in the northern hemisphere gets deflected to the right, and in the southern hemisphere gets deflected to the left. Any type of movement. Whether you have currents that are moving in the northern hemisphere, they get deflected. If you have airplanes that are moving, they turn as well, in accordance to this thing called Coriolis Force. So, back to this map. If you were to draw right arrows from each of these wind currents, you would see, pointing in these giant circles, piles of water being shoved into the center of the ocean, all circulating around in these things called gyres. Currents move the heat and temperature of the water, but they also move the water itself, right? And if you have wind blowing water into the center of this big circle, you'll pile it up, and you'll literally get a mountain of water in the middle of the ocean. Don't get too excited. The scale on the left or on the right shows you that it's only about 1 meter high. Maybe a shallow hill would be a better way of describing it. But over thousands of kilometers, this has a significant impact on the movement of water in the ocean. Gravity is trying to pull it all down, and wind is trying to pull it all together again. This causes downwelling and upwelling, which circulates nutrients all around the ocean, which affects the way that fish and other species are able to migrate and live and move. So ocean currents have significant impacts on, we've already talked about distributions of temperature, because they're carrying heat and salt with them. Also distribution of nutrients, which affects things like fisheries and other features of the ocean. So we already see some connections. The way that indigenous people moved across the Pacific, intrinsically dependent upon ocean currents. You better bet they had a good understanding of what was going on here. So, we understand one connection. Let's continue to build the web. Let's continue to weave this tapestry together.